So now that we are proof experts, we are going to prove. It's not just because your papa says so. It's not just because your mama says so. It's not just because your teacher says so. It's because it's true. All right. So today we're going to prove and apply theorems about angles. Now we've actually talked about this lovely theorem before. 4 fat words. Vertical angles are congruent. And if I had to draw that out over here, remember that vertical angles always make an X. They always make an X. And it turns out that this pair, angles 1 and 3, are congruent. And this pair, angles 2 and 4, are congruent. So you can mark it in that manner. Notice that we're not talking about angles 3 and 4. Angles 3 and 4 are not vertical. Those are called linear pair, and they're supplementary. 2 and 3 are supplementary. 1 and 2 are supplementary. 1 and 4 are supplementary. But 1 and 3 are vertical. So therefore, they are congruent. So let's prove it. Let's prove that these are congruent. Now let me just double check. Okay, there's an error on this diagram, so let's please erase. We're going to switch the 3 and the 2. Please switch the 3 and the 2. And I think that'll make better. All right. So we're given a diagram. And ultimately, notice what we're trying to prove here. In vertical angles are congruent. Vertical angles is your hypothesis. So what's that imply? It implies my Q, that the 2 angles are congruent. So again, we have a hypothesis, we have a conclusion. So ideally, just like going from Boston to New York, or excuse me, Boston to LA, I'm going to go Boston to New York to blah, 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 and end up in LA. So we're going to take multiple steps just to get to LA. Okay. So we might use this diagram over here. Should be very helpful. Our first step, we're told that angles 1 and 3 are vertical. We just are given that. Why? Because that's my hypothesis. The hypothesis is almost always your given information. Okay, so angles 1 and 3. Now, I cannot mark. It's so tempting to say, oh, Swenson, can't we just mark this congruent? And the answer is no, because we're trying to prove it. What if I asked you to define the word masticate? And besides giggling, you're saying, oh, and you look it up in the dictionary, and it says, what does masticate mean? And the dictionary would say, it is the art of masticating. And you're like, why are you using the word masticating to define masticate? And okay, so what does masticating mean? It's when you masticate. So you go back and forth, back and forth, back and forth. Do you ever know what the word masticate means? No, it means to chew. Just chomp, 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 like you masticate gum, okay? So when you use the word to define the word, doesn't help. So when you use the theorem to prove the theorem, you get nowhere. That's called circular reasoning. It's called circular reasoning. Okay, so what we're going to do is prove this whole theorem and never even use the theorem. After this, we can use it. All right, so we are told, or we know from the diagram, angles 1 and 3 are, so 1 and 2 are supplementary, and 2 and 3 are supplementary. So what is the relationship between 1 and 2? The linear pair postulate, or I'm just going to simply say this, linear pair are supplementary. Why am I going to write that out? Because every time you write it, you actually remember, not just the title, but you remember what it's actually saying. So linear pair are supplementary. So now, let's take a gander here. I'm going from the word supplementary to a number 180. Good, so now we use the definition of supplementary. Now, in this situation, it says I use the transitive property. Now, remember what transitive means. It means to go over something. So that means something has to be the exact same. So let me just summarize transitive. If A equals B, and then B equals C, I can skip over the B and connect the dots. That's the transitive property. So in step 3, what is the thing that's the same? What is the thing that I'm probably going to go over? See, look, B. B is the thing I go over. What number do I go over here? 180. So what two things are connected? The measure of angle 1 plus the measure of angle 2 is equal to, so that's this one right here, is equal to this one. The measure of angle 2 plus the measure of angle 3. There we go. So the measure of angle 1 is equal to the measure of angle 3. Why? Because the subtraction property says I can subtract the exact same thing, in this case the measure of angle 2, from both sides. Now before we finish up here, let's refresh what our conclusion should be. What symbol should I be using here? What symbol is that? It's the congruent symbol. Now I haven't gotten there yet. Is this a congruent symbol right here? Nope. But can I make it congruent? Yeah. Notice if two measures are equal, what's that say about the angles? The angles are congruent. So angle 1 is congruent to angle 3. And what property did we use, or definition? The definition of congruent angles. So in 6 steps, we proved 4 words. Now we never, ever, ever, ever have to do that again. Because, well, at least prove it. You might need to like replicate something on a quiz or something. Get the idea. So what we started with was vertical angles. Then we used something we already knew. We knew the linear pair postulate. We also knew what supplementary meant. We also knew that we can transitify things. We knew we could subtract things from both sides. And I knew I can convert this from an equal to a congruence. And all that to say, vertical angles are congruent. Vertical angles are congruent. All that to say. So we have just proved it beautifully. And now that we've proved this theorem, let's use this theorem because we know it's actually true. So here we want to find the value of the variables, which means I know, according to the diagram, that these two are vertical. And by the theorem I just proved, the vertical angles are congruent. So now I can say, since they are congruent, the measures are equal. And what we're using there is vertical angles are congruent. It's true we're using other things, but the big one that we're using is vertical angles are congruent. And now all I have to do is add, subtract, etc. from both sides. So 68 equals 4x, and then x is going to be 17. And we can always test that by plugging it back in. And when you triple that and then subtract 17 there, you'll get 51 on both sides. Great. Now the difference between the previous one and this one is once we find out what these are, I actually need to find out what the whole angle is, plugging it back in, so that I can linear pair, supplement these. So let's go ahead and set that up and do it. And here we have vertical angles are congruent, so the two sides are congruent. I'm going to subtract 3x from both sides and add 40 to both sides. So here's one of them, x is 50. When I plug 50 back in right there, or here, it doesn't actually matter, it's not probably a little bit faster right there, this is going to give me 150 plus 10, so that means 160 plus y is equal to 180. Why is that true? Because this is, these are two pairs that are linear. Linear pair are supplementary. And now the value of y is simply 20. And there we go.